All right, so what you guys are looking at is just a plastic bowl of water. I'm using plastic because if I used a metal bowl, it would null and void the test because path of least resistance would be through the bowl rather than through the water. And what we're trying to test in this theory is, does bleach have a direct effect on how conducive water is to allowing current to flow? So I'm going to do this test in kind of two phases. One, I'm going to show you the results of how much resistance we have or how conducive this environment or this liquid is to allow current to flow. And then I'm going to add bleach to it in the same sense that we would a house wash or a roof wash or cleaning brick, whatever you might find on the outside of a home that you would expose fluids and liquids to outlets. So right now my DC power supply is disconnected from this, so I'm not reading continuity through the power supply. My multimeter leads are held onto the wires that are suspended within the bowl of water. So if I just turn my multimeter on to continuity mode, immediately what you'll see is I'm already in the kilo ohms range. So right now I'm at 11.2 kilo ohms. So we're looking at about 11,000 ohms and some change worth of resistance within this bowl of water. May not seem like much, but if we were to move these wire leads closer together, or perhaps if they were installed on an actual GFCI or even a non-GFCI outlet where they were only, say, 1/4 of an inch apart, if water was suspended between those enough or just coating the outside of that outlet enough to cause a connection between the two outlets or between the two leads on the back of the outlet, you would have a serious problem there. So right now, about 10,000 ohms. This is going to sit here and it's going to kind of vary simply because there's a few factors involved with this. One, when you're testing resistance, your multimeter is actually using an electrical signal. It has to send something out in order to get something back. And it uses that correlation with how much it sends out to how much it gets back to give you a direct correlation to resistance. So as long as I leave my multimeter here, this number is going to constantly change. So I'm not going to sit here and just wait for this thing to stabilize because it's literally going to move as long as I'm here. What I want you to think about is these continuities, or this continuity through the leads. This is traveling through this bowl of water right now. Now if I plug in my actual power source, all right, now I bring that factor into the equation, immediately my resistance goes down to just 500 ohms. And the reason for that is because the path of least resistance that my multimeter's signal wants to travel through is through this power supply and then back. So I'm not actually reading through the bowl of water anymore on resistance. I'm reading through the power supply. So keep that in mind as we're doing this test, that the goal here is to see just how conducive plain water is versus water that has bleach added to it or whatever type of surfactants you're going to have added to it when you're doing a house wash. So part 2 of this test is what I want you to take away from this is that these leads are approximately 9 to 10 inches apart. All right, if they were installed on the back of an outlet within the wall of a home, there would only be about 1/4, maybe a 1/2 inch worth of space. And now once you get down inside that outlet, those leads are literally apart the thickness of, the end of a pencil. The same thickness as the prongs on whatever you were going to plug into those outlets. So it doesn't take much water at all, even a drop or two, to get within that outlet, and it's going to short that out. But just for the sake of test, my DC power supply is only capable of supplying 30 volts. Now, when you're dealing with outlets on the outside of a home, that power is alternating current. It is AC. So another thing you're going to have to keep in mind, we're dealing with DC power here. Current flows in one direction. Now, if I turn my voltage all the way up, I've got my current flow turned off right now just because I don't want anything flying through these circuits. But if I turn my current up, what you start to see is with just under 32 volts applied, I can get 0.06 amps of current flow through this bowl of water. And the reason I know that's happening is because I've actually got a very, very minor electrolysis process happening on my negative lead. The same concept that people do with like hydrogen cells, that's actually happening right here. it's not very effective, and it's not going to give you anything because, once again, it's only 0.06 current, 0.06 amps, 31.9 volts. So really nothing at all occurring there. But as you can see the bubbles coming off of it, you know there is in fact current flying through or traveling through this lead across this bowl to here. All right, so part 3 of this test is now we've established the fact that I have X number of ohms, anywhere from 11 to say 14,000-ish ohms traveling, or ohms of resistance through this bowl of water. We've established the fact that only 32-ish volts applied. I can have current flow even across this 10 inches, 10 inches of space within this bowl of water. So the fact that applying just a few drops of water or even spraying an outlet directly on the outside of a home, it's no question whatsoever that you can in fact short that outlet out. We all know that. Anybody who's spent any time on the forums has seen pictures of this happening. The third part of this test is what I want to hone down is, if you add SH to water, does it in fact make it more conducive to electrical current flow? So just taking my multimeter here, what I'm looking at is I've kind of creeped up to say 15,000 ohms. All right, I just bumped my leads. So all right, so for the third part of this test, and what we're really trying to figure out is, we know we have fairly high resistance when we're dealing with just water in a bowl, which means we would have fairly high resistance if that water was being sprayed onto a house. The only difference in that is we wouldn't be using a bowl, we would be spraying a high volume of water up against the side of a house, potentially directly onto an outlet. The question is, does your house wash mix with the chemicals that you have in it assist current flow? Meaning, does it reduce the overall resistance of the actual fluid that you're dealing with? Meaning, when it gets inside that outlet, does your house wash mix have a better chance of shorting out that outlet than just plain water? So I have my power source disconnected right now. And here is our ohm reading. So right now we've kind of drifted around and we're right around 3,000 ohms. I did have to set up my leads again because I kind of bumped it and knocked them loose. So right here I have 10% bleach. I went with 10% because I don't actually have any of the dollar store or Walmart stuff in the house. And not everybody is using 12.5%. So I figured 10% anyways was right around the good mix of being right dead center of the middle. And so if I add this to this water, let's see what happens to my resistance. All right, so right there, about a half a cup's worth, I have put enough minerals and salt into this water to completely negate all the resistance value that this fluid has. So as you can see, there is quite a bit of difference between just plain water and water that has SH added to it. There's no surfactants or anything added to this bleach. It's just straight out of the jug as you would get it from your chemical supplier. So for the second part of this test, earlier, if I passed right around 32 volts through this bowl, we got about 0.06 amps. So let me just turn the amperage on again now that we've added some bleach, and let's see what we can get. All right, so we went from 0.06 to, 20% of 1 amp just by adding a little bit. So if I add some more, as you can see, the amperage begins to increase. And we've kind of hit a stagnant point there, where now I'm starting to burn up the voltage that's available, and my power supply is basically regulating that at a half of an amp because it senses that there is in fact no load device in between this circuit. So it's more of a protective measure within the power supply than it was an actual test, so to speak. If we were dealing with a 120 volt AC outlet, the current would continue to run away from us until that circuit breaker eventually popped. If it was GFCI, that outlet would pop, or if it was non-GFCI on the external of the home and you're shorting out the outlet internals, that is where we begin to get the fire. So as you can see, the electrolysis process is in full swing. We have our basically hydrogen being created there. A very, very poor, low-grade form of it, almost not even worthy of being called hydrogen. So I'm going to go ahead and turn this off so I don't burn anything up. But for all you guys out there that were having the issues or wondering about the conductivity of Housewash mix, there you have it. Hopefully I did the best I could with explaining this with the materials that I had available. If there's anything else that you'd like to see, if there's any questions you have pertaining to electricity or the test that was done, or just Housewash questions in general, you guys know that I'm a big advocate for taping up everything anyways. Cover your ass, cover the customer's ass. Do what you have to do to guarantee the work. So there you have it. Post those questions, comments in the bottom and comment section. Like, subscribe, and give me some more ideas.